Welcome, deep divers. If you're building with AI, well, you know the headaches, right? Wrangling massive data sets, complex deployments,
hmm
and just keeping up with these large language models, it's a lot.
It really is.
So today we're going to cut through some of that noise. We want to get to the core of what's actually making AI development faster, maybe cheaper, and, more effective for you.
That's exactly right. Our mission here, it's kind of twofold. First, we'll unpack some really innovative tools that are, let's say, streamlining the whole AML project world, which is notoriously complex.
Definitely.
And then, yeah, we're going to dive into this fascinating debate. It's got researchers really buzzing about, well, the future of information retrieval,
Mm.
with these cutting-edge LLMs.
Okay.
The goal is really just to give you clear insights, actionable understanding. We're drawing straight from the source material you shared with us.
Okay, let's unpack that first part then. AML projects. It's rarely just writing code, is it?
No, not at all.
You've got this whole complex mix, datasets, model weights, parameters, config files, dependencies. It's just a lot to manage. And the traditional tools, honestly, they kind of struggle. Like, Docker's great for apps, sure, but you can't just pull one specific bit of your AI project selectively.
Right, you get the whole container or nothing.
Exactly. And GitHub. You hit size limits so fast with big datasets or models.
Yeah, those weight files are huge.
So how are teams actually solving this packaging and deployment challenge now? What's working?
Okay, so this is precisely where tools like KitOps and Model Kits are coming in. It's a genuinely elegant solution, I think.
Okay.
They're powered by this open source KitOps framework, and Model Kits basically let you package up an entire AML project, models, data, code, config, everything into one single shareable unit.
Huh.
Think of it like containerization, but really purpose-built and, frankly, much smarter for AI stuff.
Containerization for AI, but smarter. I like that. So beyond just like bundling everything, what's the biggest pain point this actually solves? That old tools couldn't. Give us a concrete example, maybe.
Yeah, good question. The benefits are pretty compelling, especially when we think about those daily developer frustrations. So one massive advantage is selective unpacking.
Ah, okay.
Imagine you just need the inference code and maybe one specific model weight file, not the whole training data set,
It
right?
just saves a lot of download time.
Exactly. KitOps lets you pull only what you need from that kit. Skip the rest. That speeds things up enormously. Development, deployment, everything.
Makes sense.
It also works as your own private model registry, which for a lot of teams is super useful for versioning and access control, especially with proprietary models.
Right, keeping things organized and secure.
And that leads straight to things like one-command deployment, which
Yeah.
just dramatically simplifies getting models actually running in production.
Okay, so it's not just packaging. It plugs into the workflow deeper.
Oh, absolutely. KitOps is really integrated into the modern MLO stack.
Huh.
It's making things like ROI pipelines or LLM fine-tuning easier, yeah.
Right.
But it's also like automating the creation of Kubernetes and K-serve configs.
Wow, okay, that's bridging a big gap.
It really is. It connects your dev environment to robust, scalable production without all that manual configuration hell. They've even wrapped the CLI and Python SDK into an MCP server to make integration even simpler.
Okay, that definitely sounds like a huge step up for packaging and deploying. But what about the other side, managing the data itself? Especially with multimodal AI, you've got storage, transformations, inference. It gets really complex, doesn't it?
It does. It's a whole other beast. And that brings us nicely to PixelTable.
PixelTable.
Yeah, it's an open source Python library, and it's designed to tackle exactly that complexity. What it does, essentially, is let you define your entire multimodal workflow, all those steps, as computed columns on a table.
Like a spreadsheet, but
Yeah.
active.
Kind of, like a superpowered spreadsheet, yeah. Each cell or column isn't just static data, it's a dynamically computed result. And crucially, it automatically updates and versions itself when your raw data changes, or even if you tweak the transformation logic.
Whoa.
The magic is really that it automates all that messy stuff. The data plumbing, the versioning, the incremental updates.
So developers don't have to build all that pipeline infrastructure themselves.
Exactly. They can actually focus on the logic of their application, not get bogged down wiring everything together.
So for me, the developer, what does that really mean day to day?
Okay, so what this means for you is, well, it's pretty transformative. First, you get incremental computation,
Meaning?
meaning it intelligently processes only the changes. So what might have taken hours of reprocessing now takes seconds. That saves huge amounts of time and compute cost and developer frustration, frankly.
Yeah, waiting for jobs to finish is painful.
Tell me about it. Then there's automatic versioning. You get full lineage tracking,
Huh.
complete reproducibility, which is absolutely crucial for debugging or maybe auditing down the line.
Okay, traceability, that's huge.
And it's a unified system. It handles the data, the transformations, the AI models, all in one place.
Mhm.
So ultimately, you focus on your application logic, not the plumbing.
Yeah.
And bonus, it's totally open source.
That really does sound like a leap forward for anyone who's wrestled with data pipelines. Okay, let's pivot a bit. There's this other thing really captivating the AI research world right now.
The big debate.
Yeah. This core question, will these super long context LLMs eventually just make retrieval augmented generation, RAG, obsolete?
That's a really good question.
It's huge because the context windows have grown just staggeringly fast. I mean, GPT 3.5 Turbo was what, 4,000 tokens?
These are like ages ago, right?
Yeah.
4,096, yeah.
Then GPT-4 hit 8K, Claude 2 jumped to 100,000, Llama 3.1, 128K, and now Gemini is talking over 1 million tokens.
1 million plus, yeah.
Yeah.
It's wild.
That fundamentally changes what these models can see at once. What's the immediate implication of that kind of scale? How does that change how you build something?
Well, it's truly remarkable progress. And yeah, it immediately makes you ask, if the LLM can read a whole book, maybe even a small library's worth of text, why bother retrieving snippets?
Right. Why a RAG?
So to really get the debate, let's quickly define them again. RAG, Retrieval Augmented Generation. It works by fetching relevant info from outside, often from huge databases, before generating the answer.
Okay.
It's really good at handling massive scale, cost-effectively, by just focusing the LLM on the important bits.
Got it. And long context.
Long-context LLMs, they process loads of input directly inside their context window. They can summarize whole documents, do multi-hop reasoning across different parts of the text, all without that external retrieval step.
So yeah, the first thought is maybe RAG is on the way out. But knowing research, there's usually a counter argument, right? What are the papers actually saying? Where's the real tension here?
The research definitely paints a much more nuanced picture. It's not a simple either-or situation yet. Not at all.
Okay.
So take paper 1, the one titled, Can Long-Context Language Models Subsume Retrieval, RAG, SQL, and More? They use the Olaf-T benchmark.
Right.
And they found that, yeah, Gemini 1.5 Pro did outperform RAG pipelines on some tricky multi-hop reasoning tasks, like on the hotpot QA and music data sets.
Okay, so advantage long context there.
And it's big. But RAG still held a significant edge when it came to scalability for much, much larger sets of documents, specifically around the 1 million token mark for the whole corpus size.
So sheer volume still favors RAG.
Pretty much, yeah. So if you have an enormous knowledge base, RAG is still looking like the way to go for now.
Okay, that makes sense for general knowledge. What about really specialized niche areas? Does RAG still hold up there?
Absolutely, and that's exactly what paper 2 looked into.
Yeah.
RAG versus long context, examining frontier LLMs for environmental review. They used the NEPA-Quad 1.0 benchmark, focusing on environmental impact statements.
Yeah.
Super domain specific, requires very precise information.
Right. You need the exact fact.
Exactly. And the results there show that error-driven models actually outperform the long-context LLMs on accuracy, especially for these niche tasks where getting the precise retrieved fact is critical.
Okay, that's a strong point for EGRI's relevance in certain fields. Then there was paper 3, a comprehensive study and hybrid approach. That sounds like it's trying to find a middle ground.
Yeah, that paper really dug into the strengths of both. It introduced something called self-root.
Self-root.
Yeah, basically a hybrid method.
Yeah.
Combines RAG with long-context LLMs. And they showed this approach could actually reduce costs while keeping performance pretty competitive.
Interesting.
Well, it also highlighted that RAG is really efficient at smaller retrieval scales. So there's this trade-off, right, between how many tokens you feed the long-context model versus performance. It suggests it's not about replacement, but finding the right balance. Maybe use RAG to find the best stuff, then let the long-context model reason over that.
A smart combination. Okay. And finally, paper 4, the ChatQE2 paper. How does that fit in?
So ChatQA2, which is based on Llama 3, they evaluated long-context solutions too, and they found that the long-context models performed, well, marginally poorer than a RAG. And crucially, they needed more token context to get even comparable performance.
So another point suggesting long context isn't just a magic bullet.
Exactly. It adds to this growing pile of evidence that while powerful long-context LLMs aren't necessarily the answer for every information retrieval problem.
Okay, so pulling all this research together, if I'm building something now, trying to decide between RAG, long context, or maybe this hybrid idea, what are the key takeaways?
Okay, a few critical things stand out. First, Cost efficiency. This is a big one.
Yeah, I bet.
Handling contexts of, say, 200,000 to 1,000,000 tokens per request. With these big, long context models, that can get really expensive really fast. We're talking potentially up to $20 per request for some models.
Wow, okay.
So for many applications, especially if you need scale, RAG is just way more affordable right now.
Makes sense. What else?
Second, domain-specific knowledge. Like we saw with the environmental paper, RG really shines when you need precise, curated retrieval of factual info from a niche area. It's just better at finding that needle in the haystack sometimes.
Right. And the third point, you mentioned something about integration.
Yes, and this is maybe the most interesting insight for me. Complementary integration. See, a lot of the time when RJ pipelines fail, it's actually because the retrieval step wasn't great, often due to, like, bad chunking of the source document.
Yeah, garbage in, garbage out.
Kind of. But if you combine RAG with a long-context LLM, the LLM can potentially reason over larger, maybe less perfectly retrieved chunks more effectively. It might even get rid of the need for super fine-grained chunking altogether. The LLM can sort it out.
So using the long context after retrieval to make sense of maybe slightly messy results.
Exactly. Use the LLM to improve RAG, not just replace it.
That's a really fascinating angle. Okay, so just when we think we've got RAG and a long context figured out, there's another thing bubbling up. CAG, Cache-Augmented Generation.
Yep, CAG. It's a very clever twist on the idea. It shifts the thinking slightly.
How so?
The core idea with CAG is instead of doing real-time document retrieval like ARG does, you preload the necessary knowledge directly into the LLM's extended context window beforehand.
So it's like the information is already in there, cached, ready to go.
Precisely. No separate retrieval step happening when the user asks a question. It's preloaded.
That sounds incredibly fast. Like the LLM just knows the answer's context already. What are the big wins with that approach?
He offers some pretty significant benefits, yeah. Key ones are minimal latency, because everything's preloaded, right? No waiting for a database lookup.
Instant answers.
Pretty much. You also tend to get fewer mistakes related to retrieval. Since the values are pre-computed or preloaded, you avoid the ranking errors or picking the wrong document that can happen with real-time retrieval.
Okay.
The architecture is much simpler, too. You don't need a separate retriever component. Just load the cache.
Yeah.
And yeah, inference is blazing fast. Once it's cached, boom, lightning speed.
And accuracy.
Often higher accuracy because the model gets this unified, complete context right from the start. It has all the relevant info immediately available to process.
Okay, on paper, that sounds amazing. Speed, accuracy, simplicity. But there have to be downsides, right? Where does CAG maybe fall short, or what are its limitations?
There are two pretty big limitations, and they're really crucial for practical use. First, CAG is inherently inflexible with dynamic data.
Ah, okay, because it's preloaded.
Exactly.
Yeah.
If your underlying information changes all the time, the news feeds, stock prices, social media preloading becomes a real headache. Keeping that cache constantly up to date is hard.
Right, so it's better for static knowledge.
Much better. And second, it's still fundamentally constrained by the context length of the LLM. Yes, context windows are getting huge, but they aren't infinite. There's still a limit to how much knowledge you can realistically preload and have the model effectively use within that single window.
Got it. So great for specific, static, bounded knowledge bases, maybe less so for the entire internet changing every second.
You got it.
Okay, so we've really covered some ground here. We've gone through streamlining workflows with tools like KitOps and PixelTable, making that whole infrastructure side less painful.
Hopefully, yeah.
And then we dove deep into this RAG versus long context debate. It seems pretty clear that while long context models are incredibly powerful and flexible, they've got real cost and scale limits, especially for truly huge data sets.
Definitely.
And RAG, well, it's far from dead. It's still indispensable, especially for large-scale stuff and getting that precise domain-specific accuracy.
Precisely. And what's really fascinating, I think, is seeing this consensus emerge around a hybrid approach.
Combining the best of both?
Yeah. And it matters because retrieval, RAG, can really help cut down the costs that using only long context LLMs would rack up.
Right. Use RAG to find the relevant bits, then let the LLM work its magic on just those bits.
Exactly. Plus, having that decent context window still lets the LLM reason over the retrieved chunks much more effectively. It helps reduce that feeling of fragmented information and maybe helps fight against hallucination too.
So wrapping this up, what does this all mean for you listening right now, whether you're building these systems, deploying them, or maybe just using them day to day?
Well, I think the provocative thought to leave you with is this. Consider how these emerging hybrid systems, they might not just combine the strengths of RAG and long context. They could fundamentally redefine how we interact with information, how we extract knowledge from these vast digital oceans.
A new way of knowing things.
Potentially. They're making intelligent systems more accessible, more powerful, and hopefully more cost-effective for you really quite soon. It's about finding that sweet spot between precision, scale, and cost. And that's where the innovation is really exciting right now.